Okay, so today we're reviewing some basic facts about triangles. First of all, what do we call the pointy bits? The fancy name.
Edges.
No, the
Vertices.
Yeah. Oh,
I've
got it.
never heard that term before.
Oh, now you have. These are vertices, okay? Vertices are labelled with capital letters. The side opposite it is the lowercase. So this side here, I could call this side capital A to C, so it could be AC. Or I could call it lowercase b, because it's the side opposite B. Okay, so this will be lowercase c, and this will be lowercase a. So we can name a side by using either two capital letters or one lowercase letter from the one opposite. Now, a few of you stuffed that up in your test on Pythagoras' theorem. You needed to be careful when you label the sides for Pythagoras' theorem.
On that question where you had to do like A's.
Yeah, when you had to say like,
I did that. Aces
you had that sorted?
Yeah. You already told me I did it wrong like when I had the booklet.
So you got it sorted. Okay. Alright, now we had a way of classifying triangles. We had two ways, one according to angles and one according to sides. So according to sides, we had three types of triangles. What were the three types? Does anyone remember?
Acute.
A right angle.
No, according to sides, that's angles. Something to do with
Equilateral.
sides. Isosceles. What is isosceles?
All equal sides.
Isosceles has how many equal sides?
Two.
Two equal sides.
One equal.
Okay, what's the next one? Equilateral. Awesome.
All sides are equal.
Equilateral.
Squeaker.
Not very nice.
Okay, all sides equal. Okay, what's the last one? We got isosceles, equilateral. What was the third type? Isosceles had two equal, equilateral had all equal. What's the other one? Matthew, you don't tap. What's the other one? When nothing's equal. Scalene, that's the one. No equal sides. Okay, looking at these two, they have two equal sides or three equal sides. They also have two equal angles or three equal angles. For an equilateral, what are the angles?
90. No.
No. Wait. They have to add up
60
to something.
degrees.
They're all
Yeah, that's
60.
back
Well
down
done,
to
Sam.
180.
They are all angles are 60. Okay, because they have to add up to 180. And for an isosceles, Lawrence, are you keeping up with us? Keep writing. Isosceles has two equal sides and two equal angles. Okay, so that's the three types of triangles according to sides. We also had three different types of triangles according to angles. Sam already told us one. Okay, so our angles. Oh, except I'm spelling wrong. Okay, so what are our three different according to angles? Sam already suggested that we had a right angled triangle. What was that, Bryce?
Acute.
An acute angled triangle.
And obese.
Maybe not quite.
Tubes.
And obese.
Obtuse.
Did you write obese?
Okay, now looking at these triangles, the right angled triangle has one right angle. Okay, so it's one right angle. And the other two are acute. Okay, so one right angle, two acute. An acute has what?
Three acute angles.
Three acute angles. What about an obtuse?
Two acute, one obtuse.
Only one obtuse and two acute. Well done. So one obtuse and two are acute. Okay, so acute must have all of them acute, but right and obtuse, they just have that one special angle that's either a right angle or obtuse. The other two are still acute angles. Alright, we've mentioned it a couple of times. The other really important fact was the angle sum of a triangle.
Is that how much they add up to?
Yep, so a few of you have already mentioned it. What do they add up to in a triangle?
180.
180. So for any triangle, say A, B and C are my angles here. So A plus B plus C, all these angles must add up to 180 degrees. Okay? Now there is one other rule that we looked at. I'm not sure if you looked at last year. It's called the exterior angle. Anyone remember the exterior angle? Where's that on a triangle?
Outside.
It's definitely outside. Exterior means outside. An exterior angle occurs when I extend one of the sides. So I'm going to extend it out here. This angle here becomes my exterior angle. Does anyone remember a rule about this? Remember seeing anything about the exterior angle last year?
Adds to 180.
Pardon?
It adds to 180.
It adds to 180, not quite.
Supplementary.
Okay, let's have a little bit of think about this one. Alright, so let's say these ones are, let's call them A and B. Okay, so I've got A and B here, and this is C. Now I know A, B and C add up to 180. I also know that C and this exterior angle, which let's call it D,
Add
have
up to
to equal
190.
180 as well, don't they? Why do they have to equal 180?
Because they have to equal.
Because it's what? Supplementary, because what shape is this? It's a straight line. Okay, so straight lines we know are supplementary, that's a 180 degree angle. We also know that these three add up to 180. Now that gives us a very interesting fact. We know that A plus B plus C equals 180. We also know that D plus C equals 180, don't we? We know both of those things are true. So if I look at that carefully, if I have A plus B plus C is 180, D plus C is 180, these things are going to have to be the same, aren't they? That A plus B is going to have to be the same number as D on its own, or else they wouldn't both give 180. So the exterior angle theorem states that A plus B has to equal D. Okay? So the sum of the interior opposite angles is equal to the exterior angle. That's the statement of the theorem. Does everyone see why they would have to be the same? Does that make sense? Alright, so I know from this diagram that A plus B has to equal this exterior angle. So as a sentence, I would write the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So that's a bit of a long sentence. So the exterior angle of a triangle is equal to the sum of the two interior opposite angles. Okay, does everyone understand that final rule? Alright, that's all our theory for today. So we've got different types of triangles, we've got our angle sum, and we've got the exterior angle. So let's look at a couple of really quick examples.
Oh.
Are we good?
Oh, what? No.
We need 30 seconds.
Yeah.
Yes, please.
Okay, copy it down.
Two.
Sleep. Oh, no, he's not. It's only semi.
Okay, now when it comes to the examples, remember, in Year 7 we were happy if you just found the answer. In Year 8 we want the answer and we want the reason. Okay,
Oh,
so
no,
you
we
can't
did that in
just
Year
Yeah,
tell
Miss
me.
Dawn said last year we still needed
Oh, good, developing excellent habits.
it. Yeah.
Alright, so
You didn't even care about the answer.
let's look at a couple of really little examples. So, let's say I've got this triangle here. What do those lines mean? What do those dashes mean?
Equal.
It means they're the same. Okay? So I'm going to put 70 degrees there, and I'm going to write x there. So I need to find out what x is. How do I do that?
70 plus 70, and then so you put them to 140.
Yep.
And then 180 minus 140 equals 40.
So the answer is 40.
Yeah.
What am I going to write on my page? So I know, everyone knows the answer is 40. How do I set it out beautifully so that everybody understands what the answer is and how I got it? What do you think I should write first?
70 degrees plus 70 degrees equals 140.
Yeah, or we could start with still saying the whole statement. We can have the 70 plus 70 plus x equals 180. Now, if I wrote a line, I've got to say a reason. What was my reason?
And because the two, like the dash things are there. And then
What's the word I'm looking for?
Supplementary.
What sort of triangle is it?
Isosceles.
So I need to mention the word isosceles because that's how you knew that that was 70, didn't you?
Yeah.
So I need to mention the word isosceles. What else do I have to mention? I've used another rule. How did I get that 180?
Because the triangle has to equal 180.
Angle sum has to equal 80. So as the reason, I have to mention two things. I have to mention the word isosceles and I have to mention angle sum. Both those things need to mention of your reason. If you only have one and not the other one, you've not given a complete reason. Okay, so to combine it together, I'm going to say angle sum of an isosceles triangle. So I've included both those things. Okay, so you need to have the word isosceles and angle sum in there for me to be happy with the answer. No. Okay, from that point, it's simple algebra to solve that. 70 and 70 is 140, so I've got 140 plus x equals 180, so x equals 40 degrees. Okay? One more example. Let's say we have this shape. Alright, so it's a little bit simpler, this one. What would I do and why?
The inside, like where there's no number on the inside, is 50 degrees because the angle is supplementary, the extra
Yep,
extra
so that
bit.
use a straight line, yep, that is,
Yep. So
that's
that's
50, yep.
50. And then so you add the 50 and the 60 together, and then so whatever's left over to equal 180 equals A because of
Yep, so
the
you've
angle
used
sum.
two rules for that one, haven't you?
Yep.
You've used the straight line.
Yep.
And you've used angle sum of a triangle. That's correct. But is there a quicker way? That's correct. It's definitely the right answer. And if you wrote all that down, I'd give you full marks. What's the quicker way? Think of the rule we just looked at.
Faster.
Not writing faster, that's not the quicker way. What was the last rule that I wrote on the board? What was it called?
A plus B equals D.
What was the name of the rule? Exterior angle. Okay, so using the fact that the exterior angle is the sum of the two interior angles, I can do it much quicker.
130 take away 60 equals 8.
130 take away 16. Okay, because I know that they have to add up to give this one. Okay, so what you said is correct, absolutely, but
Did you
it's
say
not
130
130
take away 16
take away
or
60.
60? Oh, 60.
gives us the answer.
Okay.
Yep.
Yep.
So I know that A plus 60 has to equal 130 because the exterior angle. Okay? So because the exterior, as the exterior angle has to equal those two, so what does A have to equal? So it's going to give me the same answer, but much quicker. Okay, your turn. Exercise 6C.
Do you want me?
You can stop that.